I collect the sample, I determine the test statistic, either, of course, Z0 or T0, it doesn't matter to me. And then when I draw the conclusion, I have two options, basically. Remember, when we state the claim, we also have to state the alpha. Alpha is the confidence level. So let's say in our, just a minute, the idea, I just want to explain how this works. Give me an alpha. Let's say 5%. What does this mean? Well, this means that the confidence, depending on whether we're looking at one-tail test, two-tail test, maybe I should say that first. I'll come back to this. So there are three types of tests of hypothesis. Three types. I'll come back to this in a minute. Here's the first one. When alpha is this piece, which is called upper tail test. What is alpha? Is the confidence level that we are happy with. The second possibility is when alpha is here, which is a left tail test, or lower tail test, upper tail test, or right tail test. Okay. This is a left tail test, or lower. And of course, the two-tail test. When this piece has alpha over 2, and this piece equally, of course, alpha over 2, and this, left tail test, and this is a two-tail test. Now, I can call it tailed, I can call it tail, it's up to you. Two-tailed test. So what is the difference, basically? You will see in a moment how we determine if it's an upper or lower, or right or left, or two-tail test. These three tests depend on the claim. So they are decided by the claim. If the claim says, let's say, if the claim says, well, I think that the number of smokers has increased in the population, then we're talking about this. Increased. If my claim is that the number of smokers, let's say, decreased in the population, that's my claim, then I'm talking about a left tail test or a lower tail test. If I'm saying the claim now is there is a difference, they're not the same as they used to be. The percentage of smokers is not the same as it used to be. Not the same is a two-tail test. So these three scenarios depend on the claim. Again, has increased, has decreased, these are the key words, is different than it was, has increased versus what it was, has decreased versus what it was before. It's not the same as it was before. Two-tail test. Okay. I didn't forget about this. I'll come back. Now, there are two hypotheses in each test. Two hypotheses. One H0 or H naught, which is called the null hypothesis. And the other one, which is the alternative hypothesis. The alternative hypothesis dictates whether it's an upper tail test, left tail test, or two-tail test. That's the claim. This is the claim. And this one dictates what type of test we are looking at. Left tail test, right tail test, or two-tail test. So when I start a test of hypothesis, I have to state, for example, the proportion is 0.2. That's one example. The alternative will say one of the following three possibilities. This is always carved in stone. This only has the equal symbol. The equal symbol is always in the null hypothesis. In other words, no change. Always. But the alternative has the following possibilities. If I say has increased, we're looking at an upper tail test. The other possibility, it has decreased, then we're looking at a lower tail test. And finally, proportion does not equal 0.2, so we're looking at a two-tail test. Okay, now from the sample, remember, where is my, after I collect the sample, I get this Z statistic. And I want to talk about the conclusion now. And again, I'm going to come back to correlate the alpha with the confidence level for intervals. That's what I wanted to do there. Okay. So three things can happen. Two things can happen, sorry. So let's suppose for proportions, I got Z statistic, a number. Let's say a, little a. Okay, so for the upper tail test, this is my alpha, let's say 0.05, and Z statistic falls here, or here, or here, or here, or here. That's my A. If that's the case, I cannot reject the null hypothesis. Do not reject the null hypothesis. I don't have enough evidence coming from the sample to reject it. But what if this little a is here? In other words, this little piece, this area to the right, because we are talking about the right tail test, this area to the right is smaller than alpha. Then I will have to say that the information coming from the sample is sufficient to conclude that the null hypothesis has to be rejected. The information coming from the sample rejects the null hypothesis because I got a number in the rejection area. This is the non-rejection area. What if I have this situation? Identical, right? If A falls here, do not reject. If A falls here, I reject. And this is only about the null hypothesis. The answer, the conclusion at the end is only about the null hypothesis. If the test statistic falls inside the alpha, in other words, is smaller than alpha, this number is in here, so this probability is smaller than this, this area is smaller than this, I reject the null hypothesis. If it falls here, anywhere here, this area is bigger than alpha, right? If it's here, look at this area. Bigger than alpha, I cannot reject. Same thing here. What happens to a two-tailed test? Well, here I have alpha over 2, and here I have alpha over 2. If little a falls here or here or here or here, non-rejection area. Non-rejection of H0 or H0 or null hypothesis. But if this little number falls here or falls here, I will have to reject the null hypothesis. One other thing I was going to mention is we do not accept anything. So please, we're going to review this over and over. Do not accept. The answers are to answer a test of hypothesis, number 1, reject H0. There is sufficient evidence to conclude that either has changed or is higher or lower. The second possibility is fail to reject. So there is sufficient evidence to conclude that, coming from the sample, of course. Coming from this sample. The second possibility is fail to reject. There is not sufficient evidence to conclude. There is not sufficient evidence to conclude that coming from the sample, if it's lower, greater, equal to, whatever, conclude that coming from the sample. Two more things, one more thing, and I'll come back to that table, graph that I started and I didn't finish. Errors. Possible errors. We have alpha, which is a possible error, and beta, which is a possible error. We're not going to do a lot with beta, but I have to explain what beta is. Okay, so what is alpha? Alpha is this alpha, right? So what does it mean? Reject the null hypothesis when it actually is true. So I'm rejecting the null hypothesis, but it is true. I shouldn't reject something that is true. So I'm making this error, confidence level error. What else can happen? What is the other possibility for errors? There is only one other possibility. When I fail to reject the null hypothesis, when in fact it's false. When in fact H0 is false. This is called type 1, and this is called type 2. Type 1 and type 2. Okay, so finally, let me get back to what I was trying to say a few minutes ago. So alpha, for example, if alpha is 0.05, then we are looking at a confidence interval of 100 minus 5%. Okay, so this is 95% confidence interval. If alpha equals 0.10 or 10%, we are looking at a confidence interval which is 90%. So this is the relationship between alpha and the confidence interval, or the level of the confidence, or confidence level, right? So when we talk about 95%, I didn't really say it, but that's what we meant, that alpha is 0.05. So alpha is established or picked by the researcher. She will say, if alpha is 0.05, the researcher will say, I am happy with 5% error of rejecting H naught, the null hypothesis, when in fact it is true. I know that was a lot to put on your shoulders at the beginning, but this is the language that we need to understand. We never say we accept anything. We are looking at the sample coming, the information coming from the sample, and we decide to reject. Again, I'll show exactly, again, many times how we reject and why, and fail to reject. And there are two hypotheses, the null and the alternative. This is our claim. Based on the alternative, I decide if it's an upper tail test, lower tail test, or a two-tail test. And the test of the hypothesis decides, first we state the claim, then we collect the sample, we determine the test statistics, and we see where they fall. If they fall in the rejection region, we reject the null hypothesis. If the test statistics falls in the non-rejection region, we fail to reject the null hypothesis and say, from this sample, there is not enough information to put any doubt on the null hypothesis. Okay. So I also had this page and this page. Okay, so now I'm in order. Okay, so I'd like us to discuss slowly but surely, maybe even all possibilities or all questions here. So let's start. I'm sharing my screen. I'm seeing I am. Okay, not here. I want here. So for those of you who are ahead, I hope that this was a very good review. And let's take it slowly and discuss each and every problem. Who would like to start?